Alright. Hello guys. It's been a while. But this new semester is starting up, and I'll probably get back to recording some more Prelab videos. This semester is obviously already a lot different. We're going to be doing it on our own computer rather than secure shelling into a remote desktop, or a remote server, I mean. So I'm using Windows, obviously, but once we get into it, theoretically, the operating system shouldn't matter. You'll see that I'm currently using the Windows subsystem for Linux, where I can just check out all the files. You can just shift right-click whenever you have WSL installed, Windows Subsystem for Linux, and whenever you open the Linux shell there, it brings you directly to that page. And here's a very nice command, ls, tells you what you're looking at. It's really just like a look command, like look at the current directory and see what's there. The original colors for this are actually pretty ugly. I've tried to update mine to look a little bit better. You'll see the directories. If you have directories in your folder that you're looking at, they're going to be like highlighted in a very, very ugly color. And you could either deal with this, or I could probably get you prepared with, let me see what I did here. I probably did it a difficult way, but if I change my directory, cd, if I just type that in, it brings me to my home directory. And typically, if you are on Linux or Mac, you'd see some folders there, but this is the subsystem on Windows, so the home here is kind of deceiving in that it doesn't have anything. But I did make these, and if I look at what they are, it's just a bunch of colors. It's really just colors for directories, for files, for whatever. And if we look at ll, it's kind of an advanced look command, and you see a whole bunch of more details and some hidden files as well. So obviously we have dir colors and dirk, but we don't have, everything that starts with a dot is hidden. But you'll see vimric. Hopefully you have installed vim. All you need to do is just type in vim, and it tells you whether or not it's there. And then, :q to quit if you've not used vim before. Those who are in 1050 definitely have used vim quite a lot, and I'm pretty sure we're used to it by now. But if you've not, you can go ahead and install it if you feel like using it. I know there's various other terminal editors, or you could use whatever editor you please. It's really up to you how you want to edit files, as long as you have something that edits files. But I know that people were struggling with some commands, so I'll just kind of review them. So vim is, of course, to open and edit a file. If you want to just read a file, you can cat it. So let's look at what dirk is. It's just essentially a command, really. And let's go ahead and, I like to vim to look at certain things. Let's look up my bashric, which is just kind of a bunch of nonsense you don't really need to know about. But this line here is actually what is doing the coloration stuff. I would suggest you look it up if you actually want to change your colors. It's a little bit too difficult to explain right now. But essentially, you'll need to put all the colors in your file and then add this line to your bashric. And anything that goes dot something rc is like a kind of like a configuration file for that. So like vimric, it's a configuration file for vim. And this is my vimric. This is what I'm using. You'll see I'm using the Delic color scheme. And this is really, I know vim is usually meant for you don't want to use your mouse, but I have a habit of using my mouse a lot, so I have set mouse on. And you'll definitely want set number. And it's not shown here, it might be automatic, but sets or syntax on. I'll put it in here just because. There we go. That will ensure that, you know, if all else is, if it's not working, if it's still not coloring everything, then syntax on should color everything. It just colors whatever words you have. It's the syntax. All right. And then as you saw there, I just did write. :W is a write command. And if you wanted to write and quit, it's just WC, or WQ, excuse me. Anywho, I'm going to go ahead and go back to where I was and open the shell here, because this is not fun to type out. And I'll go ahead and look. I always like to get orientated, you know, figure out where I am. And so I have a folder here dedicated to Computer Science 2050. And so if I want to go to that, I change my directory to CS, and I don't really want to type it in. I'm lazy, so I press Tab. And you'll see it converts the space into something weird, but that's fine. This is where I want to go. And I'll look in here, and I have some Prelabs. So I'll go to Prelabs. And I've already made the Prelab. And I'll keep that there. But let's say I wanted to remake it. I could either remove it by using the remove, essentially, is rm, remove, on it. So like remove pre1. But since it's a folder, I have to add the -r. It means like recursively, as in like go into the folder and all of its subdirectories and delete everything in there. And then pre1. And that's what you would do to obliterate that folder. But I don't want to obliterate it. I'm just going to move it. I'm going to move it. I'm going to rename it. But the way you rename a file, or any file or folder or anything in Linux, is you move it. So you're going to move pre1 to, how about I say pre1.0. Let's see what that looks like. There you see there's a directory, pre1.0. Now if I wanted to make a directory, I make directory. Now I want to make a directory called pre1.5. And as you can see, the updated Prelab I've just titled pre1.5. And I'm going to go into that directory by changing my directory to pre1. And you'll see autocomplete does not complete if there's others that end in the same thing. It'll go up to the most common, or to the last common character, and then it will let you decide what you want to do. And of course we're going to 1.5. And I look, and there's nothing in here because it's new. But that's what we're going to do. We're going to make something. Alright, I think I've gotten past the essential terminal commands that I think you should know. And now it's time to actually make our files. And so what you could do to start, this year, or this semester, is a lot different than last year, in the fact that you aren't using solely one file. You know, like typically last semester, I would just create a file, I would open a file for writing, and name it, you know, pre1. That's what I would, .c. And that would be the only file that I used forever. But in the real world, that's not really how things work, because typically files are going to be really huge if you do it that way, and it's just way easier if you separate things into different files. And this is why using a better editor, an IDE, like VS Code, would come in handy, because you can actually have like a sidebar, kind of like Explorer here. So like imagine if these two were like together, and the Explorer, you know, I could come over here and down-click on, you know, my documents, and I could click on a document, it would open it up in the terminal. I mean, it's kind of like what VS Code is, but I'm not using it just because I'm very much used to using the terminal. And I know there's a terminal in VS Code, but it was a little too complicated for me, to be honest. And I'll work my way up there. And if I figure out all the ins and outs of VS Code, I'll probably include them in another video. But for now, we won't be including everything in one big file. We're going to split it up into a few. So what we want to do, we're going to have a main file. And actually, here's a new command you can learn, is touch. If you touch anything, it makes that file. And as you can see, there's the file. Boom, it's there. And then again, remove it. I don't care about that file, actually. It was just, you know, it shows you what it is. But touch just updates. Technically what it does is it updates that file for whatever date and time it is. So, you know, if you were editing something for like a make file, make files are determined by the date and time something was updated. If you wanted to nudge a file and say, hey, I nudged this file, it should be updated, you can use a touch command. But if the file doesn't exist, it creates it. Typically, you won't really be using this because you can just simply vim, and vim will create it for you. But if you want to create a file without putting anything in it, you can use touch. And so I'll just touch the files that we're going to use. So there's main.c, which will house main, and main only. There will be, let's say, pre1.c. And pre1.c is going to house all of our functions that main will call, except for printf, etc., because those are standard library functions, and we'll keep them in a separate. We'll include those from a separate header file. So for now, pre1.c will have all of our functions that we have created, and then finally, pre1.h, a header file that will actually include all the other header files we're going to be using. So I think we should probably start with pre1.h. Let's look again, and you can see what we have here. I'll clear it. There we go. We have main, pre1, pre1h. Let's go ahead and vim pre1.h. As you can see, it opens up. I'm going to go ahead and include standard.io.h. And for this slab, I'm also going to include standard lib.h, and also time.h. And you'll understand in just a second. So those are those. Of course, the Prelab, it wants us to... Well, I had it. The Prelab wanted us to create our own function, and it wanted it to return a float. And I think this is where I'll pause for a second, but you can create whatever function you want to deal with this. But every function should have kind of a description of what the function does. And in the Prelab, it says it wants the function to... So I'll say takes in... So imagine there's a function here, you know, whatever. But what it's actually going to do is it's going to take in, it's going to input, you are going to input an array of floats, the size of the array, and a check value. Oh, that's what I'll call it, a check value. And so that's what you're going to input. And the program is going to output, hopefully, what the function will do is it'll look through the array, and it will find the largest number that is below the check value and the smallest number that is above the check value. And it will add them together. So it's a little complicated, but essentially you're just finding the minimum, that is greater than check and the maximum that is lower than check. And you're going to add those two together. So I'll say that here. Finds the, and theoretically it would want to return the result. So obviously we're going to want to return a float. Since we're adding floats, we're inputting the floats, and the sum of two floats is going to be a float. So we want to return a float. And remember, floats are floating point values which have decimals. And ints don't have decimals. Floats do have decimals. Okay, so finds the minimum value greater than check and the maximum value lower than check. Adds those two numbers together and returns the result. And of course, the Prelab gives you an example, function prototype, and it gives you, I don't know, I'll just say find float, find sum, because this function is kind of a weird function. I don't think it would really have any, useful applications. Not off the top of my head anyway. It probably does in some way, but who knows? Give me a practical result. I don't know. So you have to input the array, which would be a float pointer array, because whenever you pass an array to a function, it just passes you the address of the first variable and the size of the array, which is always an integer, because you cannot have a decimal number of values. It's always a whole number of values, an integer number of values. And it's never negative. So you have int array size, and then you have the check value, so float check. And so this is what the function prototype would look like. You would have your what it's called, what it takes in, and then this is what it will return. And then you should always document your code. Of course, the Prelab gives you this, but in this exact form it's a little challenging because it's a little difficult to give precisely, well, like for instance, let's say you had, for simplicity's sake, let's just say we had integers. For simplicity's sake, let's just say you had integers, and the array held integers, I don't know, 0 through 10. How about that? If the array held values 0 through 10, inclusive, and let's say our check value that we passed through was 5, then it would find the minimum greater than check, which would be 6, and the maximum lower than check, which would be 4. And it would add them together to create 10. So like, let's say, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say this was the array. We chose check to be our value. And so it goes through and it finds that 4 is the maximum value that is less than 5. And it stores that somewhere in its, in its local variables. And then it sees 6, and it sees that 6 is the minimum value that is greater than our check value. So it takes these two, and then it adds them together, and you get 10, because arithmetic, 4 plus 6 is 10. And if you're new to Vim, real quickly, because I realized, I'm just going through this, but some of you might not have used Vim before. I want to delete this line since I no longer need it. I'm just going to press delete, it's DD, like the characters DD, and it deletes it. That's how you would delete a line. Another option is just to go to insert mode with I, backspace, but that's pretty boring. And then, how would you backspace the entire thing, It's difficult. So to select the entire line, it's DD. And then if you make a mistake, you can press U to undo it. But if you want to take a line, you can copy it with YY for yank, and then P for paste. You can also delete a line and paste it somewhere else, and then undo that. P for paste. It's pretty useful. Yeah, a little quick Vim tutorial there. But again, I for insert mode, escape to go back to visual mode, colon to enter the command mode. And I'm just going to save this real quick, so I'm going to write it. And, you should always save your work, but it does a pretty good job of keeping your work saved. And in fact, if I go to the folder where we are now, you'll see that there is an extra file that it has created. It's a swap file. And you'll notice that when I quit, if I write and quit, that swap file will disappear. That swap file is only in use while Vim is working. And if Vim crashes, the swap file still remains, so you can recover your work. That's how that works. But yeah, I think we're done with pre1.h for now. And let's go ahead and work on main. I think main would be a good idea to work on from now. So typically, again, from 1050, what we would typically do in this scenario is include all of our standard io.h, everything we need, but we don't need to do that because that's all in pre1.h. So we're going to include not a system file, but a custom file of our own. Whenever we use these apostrophes, or these quotation marks, these quotation marks, that tells us that we're going to look in the directory, in our current directory. And you'll see in pre1.5, that would be these. And so it can see pre1.h, it can see pre1.c, etc. We want pre1.h because that's housing all of our function prototypes and all of our other include statements. So let's go ahead and include pre1.h. And that'll just shove everything that's in pre1.h right before this file whenever it compiles. All right. And then, of course, this is just main, so we're going to have int main, and that is it. That is all this file will store. Of course, main will be a little bit more complicated because it's not just this. This will run. It'll compile. Excuse me. It will compile, but it's not a useful program. And just to prove that it compiles, let's see. And also, if you don't have it already, but you will need GCC of some type. And the flags you'll want to use is wall and w error. Goodness, the file paths get extraordinarily long whenever you're using the Linux subsystem, which is not ideal, of course, but it's whatever. Anywho, these are the flags you're going to want to use. And then so you input whatever you want to compile. I want to compile main.c. And it compiled. And in fact, you can see that because it gave us an a.out. And I can run that a.out. And as you can see, it does nothing. Because main didn't do anything. But we know it compiles. Now, I don't know about you guys, but I don't really want to copy out GCC -wall -werr main, and then eventually we're going to have to include our pre1.c as well, and that's a lot. So this is where different people have different solutions to that problem. I think myself, what I'm going to do is I've been trying to learn a little bit about makefiles recently. And makefiles, if you have the command make, it should say that. But what a makefile is it's essentially automating this compiling for you. And so what I'll do is I'll go ahead and I will make myself a makefile. And whenever you make the makefile, it has to be worded, it has to be exactly like this, with a capital M, makefile. And whenever you make this file, and you're editing it, this actually has a specific set of rules and structure that tells you exactly how it's going to automate. And again, I'm still pretty new to using makefiles. I have this whole simple makefile tutorial up. What I'll actually do for now, just for simplicity's sake, I'm not going to type it all out for you, but I will go ahead and show you what a typical makefile would look like. Let's see. Open with Notepad. Okay, so here it is. And this allows for a little bit of a lot of substitution. So essentially, I have here, and this hasn't technically been working perfectly, but it's been working enough. And again, I'm still pretty new to it, but first off, these are variables. Whenever you use a $sign, that plugs in the variables for you. So it plugs in these for that, and when it does that, it plugs in these, it plugs in this for that, and this for that, theoretically, anyway. Anywho, I'm going to go ahead and essentially copy this. So I'll go ahead and say cc equals gcc, saves saves a character. I don't know the purpose of it really. Honestly, I don't need it. But the flags, C flags, are going to be wall, werror, and I go ahead and for some reason I include -lm and -standard C11. So, and again, I don't know completely what all this stuff is, but I do know that the standard for C has been updating, and I think this is like, I don't know, 2011, the standard of C, which lets you do a bit more advanced stuff. It always gets a little bit more advanced, but like I think there's like 99, there's like, I don't know, I think there's 80, who knows. The point is, I use these for my flags. And you can too, it's up to you. And what we're going to go ahead and do, I'm actually going to include a project variable, because this makefile can be, it can be fluid. You can actually, if I were to see, if our project name, it's going to be pre1. Our project name is just pre1, which is going to be the name of our pre1.c, pre1.h, and our file that it compiles into, pre1. So when we run it, it won't be a.out, it'll be pre1. But we're going to go ahead and say that our header files are going to be called whatever the project is, .h, because pre1.h is our header file. And then whatever other files we're using, I have project.c, so pre1.c is where all of those go, and then of course main.c. And then I don't think we need name. Okay, I see. I've done some editing to this file, and I probably put in some redundant stuff, but anyway, so %.o. I would suggest you look up a makefile tutorial. I'm just going to be copying this. And it's difficult to copy files directly from, if you're using Windows, it's really difficult to actually copy them. But, well, I shouldn't say that completely. Here's what I'll do. I'll just scrap this. If you want to scrap something completely, you can do quit ! Because if I just quit, it's going to say there's, I didn't write. It's not saved. But I don't care. I'm just going to quit without saving. And what I want to do instead is I'm going to change my directory up a folder, change it up again, Actually, I'll go to lab 0. I have a makefile built there. Okay, so here's what I'll do. I'm going to copy, which is CP, this makefile. It's going to go up a directory. It's going to go down to Prelabs, and it's going to end up in pre1.5. And you can see that I copied this makefile all the way over there. So if I change my directory to Prelabs pre1.5, and look, there's a makefile. And then all I have to do is just change it. There we go, it's all ready for me. I'm going to get rid of a few excess stuff that I don't think I need, and add in that name one. Actually, I'm gonna use a clever trick here and delete this and paste it up here. Actually, there we go. And then this is simply name, and then main.c. I think everything else should be good. But of course, instead of lab 0, this is going to be pre1. You can go ahead and pause the video and see what, and just copy this down. This is what it should be. I'm going to go ahead and right quit. Let me see what I got. Let's go ahead and see what make does. There you go. As you can see, it went ahead and did everything for us. And actually, going back to the makefile. Okay, I see. I got rid of this variable, but I didn't change it back to GCC. I would suggest you do that. Yeah, and it's up to date because I haven't changed. And actually, this is a good way to show you. If I touch pre1.c and then I make again, there you go. Because pre1 has been updated, and so make knows, oh, it's been updated. I should remake the whole thing. And it does. And if we look around, we will see just pre1. And that is our executable that we can run. And of course, does nothing yet, but it will. And the way we get the special name, is this right here, this -o. Whenever you have a -o, that changes what it's called to whatever the name is, to pre1. So you can see that. It essentially compiles it, and again, look up a makefile tutorial for all of this, but it compiles everything for you really nice and easily. Alright, let's go ahead and look at that again. Yeah, okay. Okay, now we can get back in business. Let's go ahead and check out main again. All right, inside main, what we're going to do is we need to create an array of floats to send to the function. And the way I have just now chosen to do that, not just now, but like at the start of this video, remember when I included standard lib and time.h? That was so that we could use the random function. This function here, rand. Oh, goodness, rand. What it does is it returns a random number, a pseudo-random number, from, I think it's like 0 to some maximum integer value. I don't know. And what we can do is we can use those random numbers to create an array of random floats. But of course what we're going to have to do, because if I look at rand, here's another helpful tip. If you press, so if you're on visual mode, not insert mode, if you're on visual mode and you press Shift K, it'll open up the man file, the manual file, for whatever it is you were hovering over. And oops, that's not what I meant to do. There we go, okay. You have to use arrow keys, you can go through, and it tells you all about the function that you selected. In this case, it looks like it's it might not be the C. It's not the C function rand. It looks like it's a different open SSL. That's not what we're looking for. What we're looking for is the rand function. I guess what I could do, srand is also what we're looking for. So there we go. Linux Programmer's Manual is what we're looking for. Rand, randr, srand, a pseudo-random number generator. And the manual pages are fantastic because they go into very high detail about what every function does. They are the documentation behind the standard functions. If you ever want to learn more about the standard functions, it's all in the manual. Another way to get to the manual is to, let me just go ahead and rate quit. You just type man srand, and it brings me back there. Man whatever. It's called a man page. As you can see, you need to include the standard library, and these are the prototypes for those functions. You can see that srand is needed to prepare the rand function. It's like a seed. Of course, if we were to put in, if we were to hard code a seed, so let's say for srand, remember it sets the seed for the random number generator, like a Minecraft seed. It could be any string of numbers. That would set the seed. But the problem is, every time we open this, every time we execute the pre1, it's going to use the same seed every time we open it. And that's not very helpful because that means it's going to be the same thing every single time. A way to get around this is using time.h, because time null, if I put in time null here, what time null would return is the current time, and I believe it would be in seconds since like 1970 or something. In fact, let me just see what that looks like. I'm going to go ahead and printf a long decimal using time null. Let's just see what that looks like. Oh, and I forgot to make a new line, but that is how many seconds it has been since, I don't know, I think it's 1970s. I really don't know. Of course, I think we can do math in here. Can I do it? No, I can't. Who knows how to do bash math? Not me. But the point is, you can use the time function to get, well, not a completely random number, but a seed that will change through time. So every time you run it, every time you run your function, if you're not running it every single second, or at the same multiple times per second, I mean, it should give you a new random seed for the number generator. Anywho, that's what time null does. It returns it seconds since like 1970 or something, and srand sets the seed for the random number generator. And now we can start generating random numbers. And we can use these random numbers, which are going to be integers, to fill in the floats. And there is a problem with using integers to fill floats, because integers don't have decimals. So perhaps maybe we can just divide them by 100 and cast it as a float. That sounds good enough to me. So what I'll do is I'll go ahead and make a little for loop in here. And you could also make this your own function. And in fact, you know what? I might just show that. You could put it in main. You might not want to put it in main. It's up to you. How about I go ahead and call this function fill array. But of course, I'm going to have to give it an array first. I'm going to have to make an array. So it's going to be a float array. So float array, and it's going to have, how about 20 elements in it? And if I declare the variable like that, if I declare the array like this, all it does is find space for 20 floats. It doesn't clear them out or anything. It's find space for 20 floats. Now to fill them, I'm going to go ahead and fill the array. So what fill array will need is, of course, the array itself. You'll have to pass that and the number of items in the array, which we can probably define. And what I'll do is probably define it with, how about just size? I could probably do that, yeah? And then say there are size entries in this array. And then so that's all you need, because it'll take array, which is a pointer to the first element in array, and however many floats there are in the array, and it'll fill it up with random numbers. That's the hope. So what we'll have to do is right quit this and go back to our pre1.c, and you'll see that there's going to be a lot of back and forth. But we've not yet touched pre1.c. What we need to do is actually do another include here. Include pre1.h. Both your main and your pre1.c need to include pre1.h so that they can both be compiled, and then later they can be linked. But to be compiled, they need to have all the standard functions. And having the header file pre1.h saves a little bit of typing. And depending on how much typing you're doing, or how big your header file is, it saves you a lot of work. Anyway, obviously we're going to have in here our float find sum. I think that's what I called it. It's going to take float pointer. It's going to take a float pointer array, an int array size, and float check. And then this is actually going to be the function. And then I just made a function. It's going to be a void function, because it's not going to return anything. All it's going to do is fill the array. Fill array. It'll take a float pointer to an array and int array size. But we're not checking it against anything. We are just filling the array. So what we got to do is make a for loop. And an easy way to do this is while array size. Essentially, while array size is what it is. But at the end of it, we're going to do array size minus minus. And this will make a for loop that will actually change the local variable array size. It doesn't actually change that variable because, we passed a constant to it, and it turned it into a variable here. This variable will go away at the end of the function. So why not just use it, We have array size, which is whatever size was. It was like 20. Which we need to define. Don't let me forget that, if you can. But 20 is now array size, and then array size is 20. After each loop, it'll go down 1, and while array size, so until it's 0, essentially, we want to execute the for loop. And what we want to do is fill it with a random number. So what we will do is say array it would be array size. Okay. What we would have to do, we'd have to do -1 here if we wanted to technically do that. -1 here or -1... Nah, that's fine. This is the easiest way to do it. Because whenever you're accessing the array, the array does have 20 elements, but they're 0 through 19. And so if we want to do this, it'll stop at 0. It won't execute at 0. And it will actually start execution at 20. So we don't want to use the 20th element, because the 20th element doesn't exist. We want the 19th. So it's array size -1. And we are setting that equal to a random number. That is how you get the random number. We are wanting to cast this as a float. And we don't want just any gigantic random number. We want it to be, let's say, between 0 and 10,000. And what this will do if we mod it, because a percent mods it, it essentially divides it and finds the remainder. It divides rand by 10,000 and finds the remainder. which will be anything from 0 to 10,000. But we don't want 10,000, we're going to divide it by 100 actually, because what that'll do is it will technically give us a number from 0 to 100 with decimals, and we're casting it as a float. So since we're dividing by 100, we can get the decimals behind it. So if the random number generator wants to generate, let's say it could generate 9,654, who knows, what this will do, or that's, suppose the random number generator generated some large gigantic function with a whole bunch of numbers over here. But when you divide that by 10,000, the remainder is going to be this here. And this remainder is going to be divided by 100, and it will turn into 96.54. And that's what we're going to be given, and that's what's going to be put into the function. So that's what this whole entire thing is going to do. It's going to place whatever number it generates as a float, because it has that decimal, and it's going to put that into the current array. And it will start at array 9 at the 19th element. It'll go all the way down to 0. There we go. And technically, I don't even need these curly braces, because it's just on one line. And you don't have to have them if it's just one line. It's up to you. Typically, I don't, just to condense the code a little bit, but it really just depends. It depends how I'm feeling about it, too. But I'm going to go ahead and write and quit that. I'm going to go back to main, and you can see there's a lot of moving around. And the moving around would definitely be helpful if you had VS Code's File Explorer on the side. But, you know, eventually we'll get there. For now, though, we've finished fill array, and it will just fill this array of size. Oh, but of course, size is not defined yet. Thank you for reminding me. I need to go over to my pre1.h. And to define size, I'm going to define size as 20. So if ever I want to change the size of that array, all I have to do is change this, it's got a fancy name to it, some sort of constant. Just symbolic constant, that's what it is. We just need to change the symbolic constant here to whatever number of the size we want. There we go, right quit. Let's go back to main, and there's a lot of walking around again, but that'll just fill the array. Perfect. Now we've set the seed, we've declared the array, we've filled the array. Now the array is filled with a bunch of random numbers, a bunch of random floats from 0 to 100. Now we can finally use our function. But currently the user cannot see a thing. The user cannot see what the heck they're doing. You know, we don't know what this array contains. So at this point, I think it would be a great idea to print off the array, you know, and say, what array do we have so far? And typically, if I'm printing an array, I like to use functions for that. So let's make a function. Let's go ahead and say print array of this array of size. And it's also going to be a void function as well. And while we're at it, I'm going to go ahead and go back over to our header file, because I forgot something. We need to include it in our header file too, because the header file goes first. And so the way things work, let me kind of do a little explanation here. The way the compiler works is kind of like this. So it looks to see here. Let's go ahead and vim pre1 or main.c. So let's see here. So this is what it does. Whenever it sees pound include whatever, it looks in the directory and it finds here it is, pre1.h, and it takes everything in here. It takes everything in there and essentially replaces this line with all of this. And if we're in main, and if we immediately start declaring fill array, and it's not up here, the compiler is going to be like, what do you mean fill array? You have not told me you were going to put a fill array, and it gets confused and it just stops immediately. It gets mad. So we have to put the prototype before we actually declare it or call it. We have to put the prototype before we call that function. So what I'll have to do is I'll have to say, I need to put a little bit of documentation, but what it's going to be is a void fill array. It's going to take float pointer to an array, and it's going to need the array size. And this function fills the given array size with floating point numbers from 0.00 to, technically speaking, I guess it would be 99.99. And that's the documentation for that one function. And then this next one, which is going to be void print array, float star array, int array size. This function prints the given array size as follows. And we can make it look like this. So we're going to have that. We're going to do X, or how about just A, B, C. And what I want to do is actually include a space between these. C, D, and it's going to end like that. This is precisely what it's going to print out. So I'll just go ahead and put that in quotes. This is going to be the output. So we have to, we have to be sure when we want, how do we want to use this, But we'll worry about that later, back when we're in main. For now, I need to create the print array function. And out of personal preference, what I'm going to do here is actually, I'm going to press the characters D for D to delete 4 lines and paste them here. Because I would prefer if the description of it would actually follow it rather than precede. D to D, you can tell it how many lines to delete and then paste. And then this is 1, 2, 3, 4, so I'll go D5D, paste, there we go. And then DD, because I did something wrong. Perfect. Now find sum, and this is what find sum is. Fill array, this is what fill array does. Print array, this is what print array does. Wonderful. Let's quit that, and let's go back to our pre1.c. Now let's go ahead and make the function print array float star array int array size. And all it's going to be is a for loop, essentially. So what I'll go ahead and do is make a for loop here, and we're going to go for as long as array size exists. But of course, for loops are pretty interesting. You can really fit a lot of them in at once. And I know really you're not supposed to put a whole bunch in, everywhere, but just because I can, I'm going to go ahead and put a printf in here, because you can. You totally can. And obviously what we're going to start off with is the opening bracket. And then we need to check that array size still exists, and then array size minus minus. And what we're going to do is we're going to printf simply, we're going to print out whatever's in array size. And those are, remember, those are going to be floats. So %f for floats. But we need to end them with a comma. But not all of them with a comma. The final one's going to end with the closing bracket. So what I want to do, actually, is I'm going to go ahead and say, I'm going to make another string. Just to make things crazy. And this is going to be a bit of logic here. In the middle of a printf, you know what? For you guys, I'm just going to make it a little bit simpler. I don't want it to be this complicated for the first one, because I know some of you have not really used C before. So I'll go ahead and I'll just start it off with printf here. It does the same thing. Open bracket. And then inside of this loop, first off, we want to printf the float array at array size. And actually, I realized we don't want to go backwards to the array. We want to go forwards to the array. So honestly, I'm going to go ahead and do integer I equals 0, I less than array size, and then I plus plus is technically what we want to do. I'm just trying to be extra, and it's making things difficult. But there you go. This is a very simple for loop. Starts at 0, goes to the array size, and it goes from 0 to 19 in this case, because size was 20, for as long as I is less than 20, which is 0 to 19. Anyway, this makes it easier. I can just do array I. And so this will printf. This will print out the float at whatever it is. And then, if it's not the very last one, so if I equals array size minus 1, that means we're on the very last one. That means we want to printf the closing bracket and a new line. And then that's what we're going to print. Otherwise, we want to printf a comma and a space. And you'll see what it's going to look like. It'll print a comma and a space between all the elements until it gets to the very end of the array. And then it's going to paste, or it's going to print the closing bracket and a new line. So let's go ahead and see what that looks like. I'll go ahead and right quit. Let's go back to main. Oops, I forgot. I had it open here. So let me go ahead and just quit for a second. I'm going to go ahead and exit out here without saving. That should get rid of the swap file. And then go back to main, because it knew I had it open already. And that's the thing about swap files. Vim is pretty smart with that. Anywho, it looks pretty okay here. We've made the array, we've filled the array, and now we're going to print the array. Let's take a look at what that's going to look like. Let's make it. And my bad, in find sum, I haven't even... let's go back to pre1.c, just so that we can make it happy temporarily. We've not used find sum yet, but it always finds ways of nagging at me. Let's just return 0, just to say, there you go. Make and pre1. All right, as you can see, there's 20 elements. It gives a lot of extra zeros and sometimes extra 9s because of weird floating point arithmetic, which is, it's not quite precise. And you know, maybe we should fix this. Maybe we don't want all these digits here. I certainly don't. So let's clean up a little bit. But as you can see, 73, 64, they're all in between 0 and 100. We even have a 9. So this one generated 901. That's the number that was generated. It generated 901, and then it divided that by 100 to get 9.01. Anyway, let's go back to our printf function, our print array function, and instead of just pasting the float itself, by default, it includes all those extra digits. All I need is the 2 after. So I'm going to do .2f. %.2f gives me the floating point number with 2 digits after the decimal. I'll write that and quit it. Make and execute. And there it is. And as you can see, we've got new values. it's going to have new values every time we run it because of the time. And there you go. Look, we even generated pi by randomness. We have pi. That's pretty cool. Anywho, let's go ahead and go back into main and see what else we can do. So we've printed the array. And in fact, what I want to do is I want to tell the user what we intend to do. So I'm going to go ahead and say printf this function, or this program, will take a random array of floats check them all against a certain floating point number, .2f, and add two values. New line. And the cool thing about printfs is you can just continue going on to a new line so long as you end it like that. And make sure you have your commas, and because we have a floating point number in here. And I'm just going to call it num, because we haven't yet made our check number. So I'll make float check, or float num, and I'll make it equal to, if we're in between 0 and 100, let's make it 60. That sounds good. So now our check value is going to be 60. It's just, it's totally subjective. All I did is declare some totally random number, 60, as what we're going to check all these values against. So this program will take a random array of floats, and check them all against num, and add two values. Those values being the lowest value greater than that given number, and the greatest value lower than that value. And new line. And all it is going to be num. In fact, it's going to be num, 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 because we're using it 3 times. And let's just see what happens here. In fact, I also need to say, here is the randomized array. And this is all, completely personal. It's just because I want to, not because I need to necessarily, but it helps to kind of document your code a little. All right, let's go ahead and right quit and make and run. There you go. It'll take a random array of floats, check them all against 60, and add two values. The lowest value greater than 60 and the greatest value lower than 60. Yeah, that's right? The lowest value greater than 60 and the greatest value lower than 60. Here's the randomized array. There it is, and I even included a little tab just, to help things along with organization. Maybe I could do it in front of here too. It's completely optional. The /tab is what gives you a tab. /t. \t gives you a tab. Completely optional. There it is. For a little bit of organization, anyway. Which is useful. Alright, now of course we actually need to do what the Prelab told us to do, which is to perform what we promised to perform. So, let's go ahead, and what we're going to do is we're going to vim pre1.c. We're finally going to get to this function here. Now, how in the world are we going to go about making this function? Because remember, it takes in that array. It knows how many elements are in the array, and it has a value that it's going to check against. It's going to return, hopefully it's going to return the sum. We want it to return the sum. Of course, sometimes it won't. So like, say for example, what if our number was 6? Oh wait, that doesn't work. What if our number was, oh goodness, what if our number was 1? In this particular array here, what if our check number was 1? 1.00, you know? In that case, there are no values lower than 1. It shouldn't give me a sum of anything. In fact, it should tell me, sorry, that didn't work. There were no values less than 1. So, then we got to determine, should the function tell you that, or should it return something that main will recognize, and main will tell you what happened. Whatever you do, make sure you document it, and you put that in the documentation in the header file. But I think what I want to do is I want the function to tell me that. Actually, no, that's a little silly, wouldn't it be? I think main should take whatever is given and should say. Because the function is going to return a float. It really shouldn't do any printing. Because we told it, we told it wouldn't do any printing. And if you were doing something behind the scenes, why would it randomly print something, right? So we should let main handle whatever value is given back by this function. And I remember in class, we were discussing something like this. You could either have, maybe we could change it. So let's look up the header file. You could either change this to be an integer, to return an integer, and that integer be the index of the array. Well, of course, they made it a little bit more complicated, haven't they? Because it's a sum of 2 of them. So what would it return? I think what I would do, and this is what I did when I actually made it before, because I've made it before. That's what's in here, hidden away to check later. But what I did, the approach I did, is I took. So anyway, so float. So the sum, whatever the sum is something that is. It adds something greater than check and something less than check. If you add something that is greater than check and something that is less than check, the value that you get back should be something greater than check, theoretically. If you get a value, by the very definition of what we want the function to do, the minimum value greater than check plus the maximum value lower than check, even if the maximum value lower than check is 0.00, even if it's 0, the minimum value greater than check cannot be check. So this function, if it's going to work right, it should never return, if it functioned right, if it found a sum, that sum should never be check or lower, because you're adding a number that is greater than check and lower than check, which is always going to be greater than check. You're doing addition, and we know they're not going to be negative. If they were going to be negative, then you'd have a different story, but we're not going to use any negative numbers, which gives you another option as well. If you return a negative number, that could be an error. It could be anything. So, and there are a few cases here as well. It could also return 0. So perhaps if it if it works perfectly, it outputs what it should. If it couldn't find, let's say for some reason the array, if it comes across some catastrophic error, if it comes across some catastrophic error where you give it an array containing only check, then perhaps it should return a negative number to say that it legitimately could not do anything. And then maybe if you did get something, but you couldn't find anything less than check, then you could return 0. And then if you did everything but you couldn't find anything greater than check, like if your check was 99 and the random number generator didn't generate anything above 99, that'd be an error. You can't add something and nothing. I mean, you can, but we don't want it to do that. We want it to tell us that it can't. Maybe instead it should return check itself. So we have 3 values here that we can use to our disposal. A negative number, and we can even use -1, -2, -3 for our error numbers. But I think it'd be easier if we just checked against check itself, anything negative, and 0. So this function will actually theoretically return one of 4 things. So if the function cannot find a value greater than check, it will return check. If the function cannot find a value lower than check, it will return 0. And if the function cannot find a value greater than or lower than check, like even if it were 20 size, what if it were all size 20, but somehow by some miraculous means every single value was check? What if that's the case? If that's the case, if no value was greater or lower than check, then return -1. It will return -1. There you go. And then of course we need to say takes in an array of positive floats, specifying that there can't be any negatives. Positive, and there are no zeros, so positive non-zero floats. There we go. Our documentation for this function should be complete. Now let's actually write it. Okay, so obviously we're going to have a value for the minimum, a value for the maximum, and a value for the sum. Or what we could do is just return min plus max. Of course, this is not always going to be the case. In some cases, you won't be able to return the min plus max. So I might as well just go ahead and go along with my what I had done and just show you what I did to solve this problem using specifically this prototype. I did it with this prototype. It was a little kind of, it's a little ugly, but it does the job, and it makes sense to me, I think. And it fits along with what we've been talking about with pointers, which is great. So speaking of which, obviously we're going to use a pointer. So we're going to say float pointer min pointer. That's what I'll call it. Min p is going to be the pointer to min, and float star max p is a pointer to max. And I'm going to start them off making them null. There we go. And what I did is, if it finds something less than check, it goes ahead and it starts filling in minimum. And if it finds something greater than check, it goes ahead and assigns max p to the address of max. And then at the end, after it's gone through the array, it will check to see what it has and what it doesn't have, does it have min? Does it have max? Does it have both? If it has both, if both have, changed from null to the actual value of min and max, if that's the case, then you can return min plus max. But if either one of them is null, it should not. So what we're going to do is if min p and max p, as in if they both exist, if they are both non-zero, then we can return min plus max. Otherwise, maybe you just have min p, then return that would be right. So if you only have minimum, that means you didn't find a maximum. And what did we put in? We didn't find a maximum. I think we returned check. And I can check the documentation about it, but I think that's what we said. And else if max p return, that means if we couldn't find a minimum, we return 0. And then if it couldn't find either of them, if both of them are null, return -1. Something catastrophic has happened. Now, we can go ahead and make our algorithm, because we need to go through the array and actually check all these values. And while we go through the array, we need to be checking to see if any of them are less than check or greater than check. So what I'll do is I'll make a for loop, and simply I'll make it int I equals 0, I less than array size, and I plus plus. And inside this for loop, we are going to check array at I against check. So if the given thing is greater than check, we need to do one thing. I'll do that, and then else if array I is less than check, then it should do this thing. If it equals check, we should just kind of leave it alone, because the function documentation and the Prelab itself said we're looking for something greater than check or lower than check, not greater than or equal to, and not greater than or not less than or equal to, just simply greater than or less than. So not equals. If it equals, it does not pass our test. So what we do is we say, well, if it's greater than check, that means that something succeeded. We can set one of these null values to the proper values. So first off, if it hasn't already been done, we need to set max p. So if max p is null, but we have something greater than check, we need to go ahead and fix max p. And the way we would do that is max p equals the address of max. And then we can fill up max actually, at this point, if it's greater than check, what we're going to do anyway is check to see if array that is greater than max we currently have, or wait a minute. I need to figure out what max and min here mean. Because if we remember, the function is supposed to take the greatest value less than and the lowest value greater than. So I want to define real quick that anything greater than check is going to be the max, and anything less than check is going to be the minimum. And I guess that's a little bit kind of tricky, but that's the way I'm going to have to define it. So we have here, if it's greater than check, then first off, I guess I should probably do this here. I'll go ahead and say, set it to the address of max, and then make max equal array I. But if we find something that is lower than the max, so here we have array, whatever we have in the array is greater than check and lower than the current max, then what we're going to do is set max equal to array I. There we go. And then the opposite here. So if we find something lower than check, first off, make sure that min p is set. Then else if array I is greater than the minimum, then minimum is going to be set to array I. And I believe that's all we need. And we can go through this as well. So I would go through it by hand, but it's a bit clustered, if I'm honest. How about we just go ahead and pretend like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is our array. Pretend we had that. And pretend they were in that order as well. And let's say our check value is 5. There you go. So it would start off, we have the array. The array size is actually 11, and check is 5. So array size is 11, so it goes from 0 to 10, and it adds it up. So we start off. First off, this number here, is it greater than check? No. Then is it less than check? Yes. So we're going to execute this part of code. Is min p set or not? Min p is not currently set, it's null. So what we need to do with min p is we need to make it not null, because we found something that's less than check. So we set min p equal to the address of min, and we set min equal to the array to 1. So currently, and let's keep track of this, currently min is 1 and min p exists. So I'll just say min, because it exists. So besides those, currently max is some undefined value. We don't know what it is, but it doesn't matter what it is yet, because currently it's got a null, max p doesn't exist yet, and it's what dictates whether or not we do the sum or not. All right, so then we go ahead and we don't execute the else if, because we did only in the if. And it finishes, it loops over, goes to the next value. Is it greater than check? No. Is it less than check? Yes. If not min p, but there is min p. It's been set, so we are going to skip this for every other time during this function. So else if is going to run. And we have, if that is greater than min, which it is, 2 is greater than 1, then min is now 2. Boom. Cycles through, starts at 3. 3 is less than check. We skip this because it exists. 3 is greater than 2, so we set it to 3. Now we're on to 4. 4 is less than check. 4 is greater than 3. We set it there. Now we're on to 5. 5. If array I is greater than check. Nope, it's not. 5 is not greater than 5. Then, is 5 less than 5? No. It completely skips 5. It goes to 6. 6 is greater than 5. But there is no maximum yet, so we have to execute this part of the code. Max p is now set to the address of max. And then max is set to whatever that is, which is 6. There we go, 6. And then there's no other else ifs, and everything is greater than, so we're not going to execute this anymore. Now we're solely on here. So 6. We finished 6. Let's go to 7. 7 is greater than 5. Max p exists, so we skip this line of code. 7 is not less than 6, so we don't do that. We go to 8. 8 is greater than 5, but 8 is not less than 6. Go to 9. 9 is greater than 5, but 9 is not less than 6. And then finally 10. 10 is greater than 5. Max p already exists, but 10 is not less than 5, so nothing executes. And we go to this final bit here. Now, are both min p and max p in existence? Yes, they are currently in existence, pointing to min and max. Then, and only then, we will return min plus max. 4 plus 6, we return 10 from this function. That is the ideal case, of course. However, if we had, say, just these here. Let's say we just have those. And a quick way to delete a word is CE. Actually, depending on what it defines as a word, it will do that. If you wanted to delete to the end of the line, you can do, I think it would be C for clear, and then a $sign. And that clears it to the end of the line, and it actually begins to start typing afterwards. Clever little Vim trick. You can learn a whole bunch of those from other tutorials as well. Anywho, let's say we had 1 through 5. If we were to go through here, and our check is 5, everything is going to be less than, which means max p is never going to be set. And if max p is never going to be set, then this is not going to be true. This will be true, however, and it will return check. Because we couldn't find anything greater than check, we return check. There it is. And so on. If we had 5 through 10, it wouldn't be able to find min, and it would skip these two, and it would execute this and return 0. However, if we had 5, 5, 5, 5, 5 all the way across the board, then that would be this final one. It would return -1. And now that that's done, I believe we are finally ready to complete main. Let's write and quit that, and let's vim main.c. Now, finally, with all the pieces in place, now main just has to take the logic that we have created in our findSum function and put it to use. Make it user-friendly. So what do we have? So there it is. Here's the randomized array. There it is. It even created a new line. Print array ends in a new line. And then what we're going to do is we're going to say we're going to do it one of a few things. What we should do is we should probably, and you cannot use, the problem with floats is that you can't use them in a switch statement. You really just have to stick with else ifs. And that's not terrible. But what we'll do is what we should do is we don't want to run the function. We don't want to run the function thousands of times just to get through an else if. So what we should do is we should declare a variable. So float sum equals find sum with array given the size and whatever num we wanted to check it against. Now sum is set to that. If sum is greater than check, that's what we want, then, and only then, we can print the calculated sum is 0.2f. New line. And that is going to be whatever sum is. Otherwise, if sum is exactly equal to check, then we need to printf. I believe in this case we were missing a maximum. There was no value greater than check, than percent 0.2f. New line. And whatever that is actually going to be num, because that's our check number. Otherwise, if sum is actually, if not sum, that means if sum is 0, if not sum, printf, there was no value less than 0.2f. New line. Num. And then finally, else. If sum is less than 0, printf, a catastrophic error has occurred. And you know, maybe it might not be. Oh gosh, how do you spell occurred? And it might not be a catastrophic error, but I think that would be pretty funny to see. I have to look up how to spell occurred now. It's either one C or one R. Oh, it is both. Okay, never mind. 2 C's and 2 R's. There you go. And that is it. That is all we need. So, let's see what happens if we make it. What did I do here? Check. My bad. I meant to check it against num. I did it multiple times, apparently. Here we go. There we go. Now I can run pre1. Here it is. So, it takes a random array of floats, checks them all against 60, and adds 2 values. The lowest value greater than 60, and the greatest value lower than 60. Here's the randomized array, and the calculated sum is 114.77. And we can run this as many times as we want. And you know, there's a chance, probably a slim chance, that we will run into an odd issue. Also, you'll notice if I run it multiple times in a second, it gives me the same exact thing. That's just because, remember, the seed we used was the seconds, so if we use it multiple times in 1 second, it's going to be the same seed. And I guess you could probably fix this somehow if you use microseconds, if you know how to do that, but I think using seconds is more than enough. But there you go. That's that. Now if I go back into main, let's just say I wanted to change num. Let's say I wanted to make it 10. This will change things, probably. This will change the chances of things for sure. Let's just see. Now the sum is 16.19. I'm hoping to get nothing below 10. If no value is less than 10, then it should fail. But I keep getting lucky, probably because there's 20 elements in the array. Well, I can fix that. Let me go back to pre1.h, and let me just decrease the size. How about I make it 10? Now let's make it. See, I get this too, and I don't know precisely what I've done in the makefile. But changing the header file didn't change this. It should have, but it didn't. And I'm not completely sure why. I'm not completely sure why. And again, to perfect makefiles, you have to look them up yourself. Anyway, I'm going to go ahead and touch pre1.c, which I know the makefile checks. And there you go, it goes ahead and updates it. And let's see here. And as you can see, it's actually a lot shorter now because there's only 10. There we go. There it was. Here's the randomized array. No value, as you can see, is less than 10. There you go. It returned that because it can't calculate a sum if it couldn't find anything less than 10. All right. That's the Prelab. I did not expect this to go as long as it did. My apologies with that. Hopefully I will include timestamps with everything. And I included a lot of tutorial bits for those still new to C. And this class is a real oddity. Because first off, it's completely different than what we did last semester with 1050. And we have those who have not been in 1050 and who are joining. And we have more yet who have not even had C practice. Anywho, I hope this was worth everyone's time. I hope you learned something or two. And it's difficult sometimes to understand exactly the way somebody arrives at a certain solution. So the algorithm I used, and we can go into a little bit more detail about it too. The algorithm I used eventually we'll talk about big O notation. And big O notation is like, how efficient is it? This goes through the array once. And it goes through the array once, which means it would have a big O notation of in. At least I think so. I'm pretty sure, yeah. As far as I know, it only goes through the array once. And it makes all this stuff. And remember, it saves it as a variable. It saves the sum as a variable to be used again. It doesn't call the function repeatedly. It just calls it once. And it goes through the array once. So this function, findSum, has a big O notation of in. And we'll learn about it later. But if you're interested in that stuff, I'm pretty sure mine fits in. Again, it's really just finding minimum and maximum, which is like almost always in. I don't think there's really any minimum or maximum algorithm finder, a minimum or maximum finder algorithm that isn't in, because it's a pretty simple function. But again, we'll learn about that later. But the way I thought of doing the pointers, it's really difficult to explain my thought process behind it. And I know I had already done the Prelab, and I just kind of copied what I had done. So that thought process is a little bit lost. But I hope that it's okay that I sacrificed the thought process in favor of maybe a cleaner video. What do you guys think? Would you prefer having the thought process, but having the code a little messier at first? Or would you prefer the code be clean and my thought process be kind of hidden? I think you might want to hear like my thought process behind it. It might help you to learn how to make algorithms. And I'm not even the best algorithm maker, but seeing into somebody else's mind, like if I could watch somebody else's video and see their thought process, it opens my mind, because oftentimes they think of something that I had not. Like doing it with pointers, I don't know how many people would have thought to do with pointers. It is a lot of extra like space, I will admit that, but it does use the function as provided, with some caveats, with some extra documentation. Anyway, yeah, let me know what you guys thought about that in the comments or in the Discord server. Besides that, thank you very much for watching. Sorry it took so long, and see you all later.